Hey everyone, here's another video. This one's going to cover chapter 7.3 from the textbook, and that is addressing present value, that is PV, present value, of an investment using compound interest. Now, the reason why, let me clarify. The textbook uses the word PV, but essentially this part is actually, in your previous formula for compound interest, the formula was amount is equal to present value plus 1 plus r divided by the compounding period all to the power of n times t. Present value is basically, what is it? Whatchamacallit? The present value is essentially, we're talking about this, right? For in typical mathematical calculations for interest, we talk about that as principal, as in the amount of money you have now, and if you let it wait over a certain amount of time, building a certain amount of interest, right? What is the future value you're going to end up with? So that's the context of the question. So take a look at this word, present value. The present value, the current, the today value of your investment. Between A, P, interest, and time, which one do you think PV, or present value, stands for or represents? Going once, going twice, you guessed it, PV is actually the principal. I don't want you to confuse this new chapter as if it was something you've never done before. I'm just trying to explain to you that 7.3 tries to spin off the same formula using different, I guess, variables. But if you know how to read a question carefully, then you'll see that it's exactly the same thing. So as opposed to trying to get you to do a completely new formula, which is this, okay? I'm just gonna get you to read, just improve your skills in reading, and we will plug in the same numbers in the same variables you already studied. Being flexible with how you refer to it, because just like y equals, x squared plus 5 or some kind of formula, y could represent height and x could represent, let's say, distance, right? In a grade 9 or grade 10 question. In the same way, just read a question, see what each number represents in the original compound interest formula, and you're golden. Okay, everything else is going to be sauce. So let's get started. Sahar wants to invest money today. That's your keyword, money today. That's going to be present, right? Present value. To have $1,000 in 6 years. I'm going to end up with $1,000 in 6 years. The future value, in other words, the total amount that you're going to have in the future is going to be 1,000. The amount of time I'm dealing with is 6 years. If she invests her money at 5.75% per year, so the rate is 0.0575, compounded quarterly, the compounding period is 4 times per year, how much does she need to invest? In other words, how much does she need now? What is the present value? In other words, what's the principal? I hope that makes sense. Go back to the beginning of my explanation to see if you caught how I interpreted every single detail in this short 2 sentences. All right? Without further ado, I'm going to plug it in. I know, without any of this future value, present value business, I know that the final amount is going to be the principal multiplied by some interest rate to the power of compound period times time. The final amount is going to be 1,000. The principal, or the present value, I do not know. This is 1 plus 0.0575 for the entire year, but that's divided by 4. And then that is 4 times 6, that's going to be 24. From here, take a look at this section I explained. The textbook tries to teach this section like it's a new formula. It is not. As long as you know how to read carefully and isolate the correct variable using algebra, I'm going to make this simple for you by solving this entire bracket. If you can do this, you don't need a new formula. You just need to be careful with how you work the calculator. So if you did the exponent portion correctly, you should end up with 1.408526078. Okay, that's some decimal. How do I get P all alone? Well, you're going to divide both sides by 1.408526078. That gives us a principal value of, I'm going to write this down, $709.96. It's rounded because I'm dealing with money. If I want $1,000 in 6 years, I need just under $710 now. And that is 7.3. Are we good? If not, go back again. See if you can recognize the wording, see if you can interpret it carefully. I'm going to go through a couple of other examples because just as how we gave all the information other than principal, I could also rearrange the question so I give all the different numbers necessary except maybe something else. So I like to show you how that might work out and how you can get around those type of questions. I'm going to clear this screen in a couple of seconds. Before I forget, this is your homework, page 441. Please try number 1458, 1314. If you have time to do more, please do more. It's going to help you because 7.4, I start getting into a little bit more of the hefty stuff when it comes to finances. So clearing the screen in 3, 2, 1. The next example I'm going to do is from the same section, but unfortunately, the textbook gave us an example where you can't finish it without either using math in the grade 12 curriculum or a computer sort of calculator helper. So I'm going to take the example from page 438 and put my own spin to it. Okay, and I think a question like this is going to be valuable to you because you might get something like this, and up until now, you don't have the math to do it. Unless you took grade 11 chemistry, you might have the idea of how to do logarithms. If not, you're going to have to bite the bullet and do a bit of guess and check for now. If you know how to do logarithms or you're interested in learning for yourself, feel free to do so. There are lots of resources online, and it's probably a lot more simpler than you think. And they make calculations like the example I'm going to give you easy, but the choice is yours. So Tamara received $250 for her 14th B-Day, which she invested at 6% per year. One day, after a certain number of years, she, what is it? I guess removes, or she cashes in on her investment, which was now worth 317.62. If the interest was compounded 12 times a year, compounded monthly, how many years did she invest? Okay, so it's my slight spin-off. There's a purpose to this, so bear with me. All right, let's go. Breaking it down, let's draw our attention to some of the, I guess, information, the numbers that the question gives us. $250 was received. She invested at 6%. After a certain number of years, in other words, I don't know the time yet, she cashes in on her investment, which was now worth $317.62. If the interest was compounded monthly, how many years did she invest? I think it's pretty self-explanatory what they want, but let's break it down. This is something that she received in the past. But if we're talking about an investment, what is the number that we started with on the investment? What is our What is our current value? What is our principal? What is our present value, so to speak? That's $250. Okay, which she invested at a rate of 6%. After a certain number of years, bam, that's already, we don't know, she cashes in on her investment, which is now worth, so the final amount or the future value. See why I don't like the words present value and future value? It can get confusing when we're already talking about the past. If the interest was compounded monthly, therefore n is 12 times a month, 12 times a year, how many years did she invest? Well, let's plug it in. If A is equal to P1 plus R divided by n to the power of nt, 317 and 62 cents is equal to 250, 1 plus 0.06, so 6%, divided by 12, all to the power of 12 times time. Okay, let's work it out. I'm going to divide both sides by 250, 762, so that I can isolate the exponent portion. And I'm also going to simplify the bracket portion so I know exactly what number I'm dealing with. This is 1.005 to the power of 12t. So at this point, the question is, what the heck is that? If you remember our exponential functions section, our chapter, you may remember that the only way to solve this, at least in our level, according to the grade 11 curriculum, is to guess and check. Yeah, you heard me right, guess and check. If you want to use log, you may want to go find it, a resource on the internet. Okay, so I'm going to actually test 1.005 to the power of 50. What is that? Ooh, I was close, 1.283, but I went way too far. So how about I try to the power of 45? Ooh, a bit too low. Okay, it's got to be somewhere in between. But seeing as how 50 was actually closer, I'm going to try 49. And that brings me, 1.27684. Pretty close. I'm going to take a look at 48 to see if that is even closer. And then I will make a decision. Well, look at that. Okay, 1.270489. I think it's pretty close. So I'm going to estimate that 1.27048 is actually 1.005 to the power of approximately 48. What does that mean? It means 48 and 12t are going to be the same. That means t must be 4. 4 years invested. So I guess she cashed out on her 18th birthday. Okay, so there are questions like that. Example 3 in the textbook gets you to flex your muscles a little bit in seeing which one is the better deal. You might recognize questions like this from grade 9 and 10. Clearing this screen in 3, 2, 1. All right, example 3 from page 440 goes like this. Lamar wants to borrow some money now to buy a motorcycle and some riding gear. He estimates that in 5 years, he can pay back an amount of $12,000. Which of the 2 loan options should he choose and why? So option 1 is Regal Bank, like Royal Bank, charges 8.9%. Oh, wow, that's a lot of interest. Interest compounded semi-annually. Suburbia Credit Union charges 8.4% interest compounded monthly. Ooh, 0.5% does make a difference, but so does the amount of times we compound a year. So, decent question. Let's try it out. He's borrowing money now, so he has to pay back later. In other words, he's going to take a look at current debt. The present value of the debt is this much. What is going to be the final amount of debt that he has to pay back if the interest is, so case number 1 with Regal Bank, if the interest rate is 8.9% and it is compounded semi-annually, so twice a year. Oh, 5 years, time equals 5. Or number 2, the Suburbia Credit Union is rate 0.084 compounded monthly. Let's take a look. The total amount if $12,000, 1 plus 0.089 divided by 2 times 5, versus the final amount if $12,000 is at 8.4% monthly for 5 years. 0.089 divided by 0.089 divided by 2 plus 1 to the power of 10 multiplied by 12,000. Oh my goodness. Don't ever do that, okay? Number 1, any kind of motorized vehicle, unless it's a classic, it's already a bad investment. You only get it if you absolutely need it. And at the same time, if you're making a bad investment by borrowing money, oh, you really better need that vehicle. Okay? Come talk to me if you want to talk about smart investments versus bad investments and what you can do to get rich as fast as possible. 18,238. So, yeah, even though this second bank is compounded monthly, the 0.5% difference makes a huge difference. So therefore, Suburbia Credit Union is a better choice for Lamar under these circumstances. I'll tell you right now, I think if you did it for another year or two, even though the 0.5% difference might be big enough, the compounded number will take over. So it's no longer about the actual interest rate, it's about the amount of times you compounded. That's going to make a difference. Once again, please try the homework. I believe it was page 441, number 1458, 13, 14. 1, 4, 5, 8, 13, 14. Okay, give that a shot. Really be comfortable with with the compound formula, compound interest formula, because 7.4, we're going to use it in a very interesting way that deals with money and mortgage and stuff like that. Okay? Good luck, and email me if you have a question. See you later.